Yes.
Everybody
Yeah.
got it?
Yeah.
Yes.
Yes.
Okay, so for the time being, because due to the time limitation, so I would probably spend 12 or 15 minutes to show you how to run the correspondence analysis and also how to interpret the result from correspondence analysis using the HBAT data file, which is mentioned in our textbook. So this morning, I already shared you three data file, right? Three data file of this example. One is corresponding HBAT corresponding individual, HBAT corresponding, and the last file is HBAT CA ready. So why do I have to share you three different kinds of data file? So let me move to the if you still remember, just imagine that, and let's get back to the context of the study that we may familiar with last week, where the HBAT manager are trying to position the HBAT performance based on the respondent or the potential consumer with respect to some of their attributes to see and to understand how a firm image is compared to other firms in the market. So they survey in total of 18 respondents, and those all of the 18 respondents are mid-level personnel of different companies. So they will rate based on they will give a response in the internet surveys, and so in total they have we have 10 competitors. They have 10 companies, including HBAT and another 9 major competitors. So we will have 8 attributes will be used in this example. Yeah. So let's look at this example. So here, if you look at the table 3 in my presentation, maybe you see this is one of the snapshot of the response they collect from one particular respondent. So you see here, all of these are represent in 1 and 0. So the binary form rating. So it's just as Professor already mentioned, is based on the chi-square. So each firm will be rated according to the 8 attributes, and the respondent, I mean the 18 respondent will give their rating on each of the respondent for each firm. So as you can see here, there will be the maximum number here in each of this column or each cells is 18. So for example, the firm A have 18 for the technical support. So that means that all of the respondents appreciate the technical support given by the firm A. Similarly, all of the respondents appreciate the warranty and claim for the firm A, which is represented by the highest number of the individual columns. In this case, column represent the firm.
Everybody know how you get the data. For example, I am a customer in this industry. I base on these 8 attributes about the product quality, advertising or warranty claim, pricing, to evaluate or to judge how many firms, you see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Totally, you have 10 competitive brand company. How about this 10 company competitor in the same field? the responder number 1, I am the first customer or manager. I want to judge, okay, HBAT company, their quality is good. I give them 1. But A is not good, so I just give it 0. B is good, C is good. So that means yes or no. Okay, D company not good in their product quality, but E, F is good, G is not good. Okay, just yes or no, yes or no. How many you can vote to these 10 company? If they are okay, you just vote them 1, not is 0. So totally how many respond? They got the average here. Okay, they got the average. Maybe you are multiple choice. So maybe next week I will show all of you to how to deal with the multiple choice questionnaire. Your feedback data are multiple choice, something by binary, yes or no, but something you just ordinal data. Okay, how to deal with the multiple response, multiple choice, and convert into cross table, and then you can do the MDS or corresponding analysis. Okay, so that's why Learn spend this time to explain how you get the data from the beginning. Okay, that's
Yes.
a job. That's a children. They know the McDonald's, but they never saw what is a chicken like this. That means you can do the analyze, but you just based on the cross table, but you never correct the raw data from the beginning. So you need to do some data cleaning and outlayer did it and rearrange into a very neat class table. And then you can do the other analyze. Okay, go ahead, ma'am.
Yes, so referring to the upper part of the table 3, as you can see here on the screen, let's open the SPAT correspondent individual. So this file shows the raw data file of all of the respondents. So you can see where on the very first column, the ID column, which is we have a total of 18 columns. And in total, we have 144 rows here in this data set. Why? Why is we have a 144? Because we had 8 attributes, and we then multiply by what?
By
18.
18.
Yeah, and then we come up with this number. Yeah, so basically all of this, for example, each, you can see here, the first 10 here. This is the respondent, the first respondent. This is the data collected by respondent. The first, the respondent number 1. Here is the from respondent number 2, and
Okay.
they are read on each of the every firm with respect to these 8 attributes. So this is how the individual file is composed. And then if we move to and then they take the average, or they take the count. They take the count, and then which is referred to this number, this table, SPAT correspondent here.
Okay.
You guys can see here. Just count it, and put it in another way to represent the data. But it's not, we cannot use this data file to run the correspondence analysis. We have to transfer it. So the way we transfer from this table, or I would say from this table, I will transfer into let's open the last data file, which is SPAT ready. So that means it is ready for running for the correspondence analysis. So here I got it is, so the first column is the firm, the firm, which is the range from 1 to 10, because in total we have 10 firms, including SPAT and other 9 competitors. So
Yes.
the code was from 1 to 10.
So
the second
label as the column, right?
Yes.
Firm as your column, right?
We can decide. You can choose.
Yeah, you can put a label here.
Attributes. How much attributes? We have 8 attributes. So
Yes.
it's been coded by from 1 to 8 here. Yeah, and this is the frequency. So frequency is just the count.
Yeah,
The
integer.
count. So I just move. I just collect here. I just copy from this. I transfer from this. This is taken from the textbook, and I move it here, and then I will change it, convert it into this one. So for example, this is the first attributes.
Column and
The
this
first
row.
attribute. Yeah, this is frequency. Yeah. So let's see. This is from 6, 6, 14, 10. So let's see which is correct. 6, 6, 14, 10. So you see here. This is the X6. The X6. Why? Here, 6, 6, 14, 10, 11.
Yeah.
Yeah, so from the row, we reverse now into the column. You understand? Reverse now from the column, from the row, and now we convert into the column. So that is how respect similarity we can do is with the second attribute, and then third attribute until the 8th attribute. So we have 8 attributes, we have 10 firms, so total we have 80 rows here. So this is how we can transfer it, and by now we can make it ready to run the correspondence analysis. So let's back to here. Here we will see a professor also done it out. So I will zip a little bit fast. So here we will turn the firm on the row and the attribute into the column. You can decide, you can switch around. You can switch attribute into row or the column as a firm. It depends on you. It's just the way you present your data, just fine. It doesn't matter. And then you go into the first, into the model, and then we take some tweaks on statistics and the plot. So here, let's just keep it in the dimension as default 2. We base a distance measure on chi-square, and normalization method we choose as symmetrical. The statistic box we choose all of the sitting here except for the permutation of the corresponding table and the confidence statistics for. So all of these 5 options are required. The plot, we want to see the biplot, the row point, and the column point. Why we need the row point and column point is because it will give us the evidence to show how it's related to the how I say the position with respect to row and column, which is very important when we interpret the result later on. And then if we run it, the first column we will receive is this. It's called correspondence table. So this is on the first row here. We see the 8 attribute, and here is the 10 firm. And we also have active machine, which is so basically this is just the column total, and this is the row total. This is the grand total. We sum it up all of this. We get up with this 851. We cover it up all of this. We come up with the 881. So the row profile. The row profile here is basically for example, we divide 6 divided by 92, and then we will get these results. Similarity, we get 15 divided by 92, we will get this result.
Yeah.
It's just a row profile.
Yeah, row profile.
Similarity, we have also column profile. Again, we can divide 6 divided by 84. We will get this value. You understand? Or yes. You get 14 divided by 84. We will get this number. You can decide. You can calculate if you want, but this is exactly what it means. How it is calculated. So once we run it, so we can determine the dimensionality of the solution. So there are two ways for us two remarks that you have to consider when deciding how many dimensions you want to keep. So first, we have to evaluate the cumulative percentage of the variation that is explained, and then we can determine the appropriate dimensionality. And now, if we stay in this step, we have to, or the researchers have to balance the design for the increased explanation in adding additional dimension in comparison with the interpretability by creating more complexity with X-dimensional add. So let's look at here for more simplified. So here Professor also mentioned this is a singular value, but it's actually the correlation between the row and the columns, and they can refer it as an eigenvalue in PCA. This is initial. This is basically the normalized chi-square. This is the account, the proportional of initial account for this is the percentage explained, and this is the cumulative percentage is explained. So we have a two-dimensional solution in this situation can explain in total of 86.3% of the variation, whereas the increase to 3 dimensions here. So these two here, based by both, can explain 86.3% of the variation. But if we jump from 2 dimensions to 3 dimensions, it only add up to more than 10.6%. So that's why we have to, the second note here, we have to balance the design for increased explanation in adding additional dimension versus the interpretability when switching from 2 dimensions to 3 dimensions. Is this work? So in this case, we see that this the 2-dimensional solution is deemed adequate for the further analysis. So this is basically how we can interpret this table. This is Professor already showed us where is how can this number appear here. We just divide the chi-square value divided by the sample size, and then we get the value here. Now the last question is how can we interpret the correspondence analysis results? So I take this 3 point from the textbook, and they said that we have to assure at least three issues here. So we have to consider the positioning of rows and columns category. So now we have to look into the firm size, and then we get it into the attribute size to see, and we have to evaluate the association between the categories in terms of their proximity in the perceptual map. And the second point is have to characterization of the dimension and assess the coordinate fit. So these three points must be addressed when we interpret the correspondence analysis results. So take it into the practical. This is the relative position of categories. So this particular slide I want to see on the firm side. On the firm side, yeah, in terms of here, the firm side here is columns. And now after we consider the column, we will go to the row, which is the attributes. So the firm side here, you can see here, I just copy the output from SPSS and put it here, and then I draw this to two lines to divide into the 4 quantiles. And you can see here that so this is the perceptual map. You may find familiar when we run the multidimensional scaling, right? So this is basically demonstrates the relative proximity of both firm and attributes into a single map. So the first point I take away note here is just that we have A, E, F, and Y. A, E, F, and Y here form one group. This is on the triangle here. These 3 firms are clustered together or position in a one group, form a one group. The C, D, H, and B, C, D, H, and B here form another two similar subgroup. Because why? Because it's located in the lower position when considering the dimension 2. They are under the value of the 0, right? The negative value here with respect to dimension 2. We see the firm G is more isolated and distinct. And the last thing could be noted here is the F and E. F and E here are now seen as more similar to SPAT, because we see the proximity or the distance between the firm E and SPAT is very close. So this is the something we can note it down when we look at the relative position of the firms. So now we look at the attributes. This is the relative position of the attributes. So remember that we have the 8 attributes, and they are all represented in the perceptual map here. So we can see that X6 here and X13, the competitive pricing and product quality here are negatively related. They are positioned as the very opposite position, right? X13 is very high and have a positive value, whereas X6 is below to the negative side in comparison for the dimension 2, right? So, and the second is we have X16, X18, X8, and X14. This one here appear to have a high associations. That means that all are in close proximity. They may be close in distance, they may be close in the similarity, or we can close in dissimilarity. We don't know whether the proximity here refer to the similarity or dissimilarity, but here these 4 the attributes here are very high associated with each other. And the last one is X12 here. We say cell fox images is very isolated from all the other. So we may now ask ourselves, is an attribute's contribution to each dimensions a more appropriate perspective? And then you can continue and look at the further output table. So this is our further output table. Look at it here. We can see that this is an overview of column point, and the second, the latter point, the latter part of the slide is overview of row point. So column and row again. Now let's look at this part. You see that X12 and X8 are the primary contributor for the first dimension. So this is a score in dimension, and the X12 and XX have a high contribution for the dimension 1. Don't bother about the negative side here. This is we take into the absolute value of here. So you can see the value on the value here. This is the highest number, the highest value, and so this is the second highest value. So that is why the self-found images and technical supports are two main primary contributors for the first dimension. Together, these two attributes can explain 86% of the inertia of dimension 1. We just sum it up this number with this number. So all of these are, again, alone, these two attributes alone can explain 86% of the inertia of the dimension 1. Similarity, we can see X6 product quality and X13 competitive pricing are the two more key contributor for the dimension 2, right? And together they can account for how much? 83% of the inertia of the dimension 2. That's the case. These key notes, these notes can be used to interpret the result. And then so this similarity we can refer to this the upper the lower bound. Yeah,
等一下
yeah.
学你的 Statistica 的 smoking 的例子。
Okay.
需要跟范例，我要叫他们用 Statistica 做功课。哎
Yeah. So if you look into the lower part of the table, you see that so the firm A, firm C, and firm G here, the absolute value, the value is more than 10%, right? While the other is less than 10%. So only these three firms are manifesting the highest contribution to the dimensional one. So firm A, firm C, và firm G could be noted down because they contribute largest to the dimensional one. Also, whereas the firm B, firm D, and this firm G, these four firms are contribute for the dimension 2 because all of these are with all our own. These four firms are own contribute greater than 10% of the for the dimensional 2, whereas all of these all of the other are just less than 10%, right? So this is how we can note it down to interpret the result, and then we can merge it up, merge these two together. Yeah.
Something like our high factor loading.
Yeah, exactly. Yeah. This is referred to the fit index. That's why, because here we can access the volume of fits of the individual categories. So if we look at here, it's a very right part of the table. We can see here, although for example, X6 and X12, we see the total of the contribution of dimension to the initial of point are very, very high.
Yes.
Are all with approach more than 99%, whereas the X14 warranty claims only exhibits the lowest value. So we can consider to drop the X14. And also here for HBAT and firm I, there are so the lowest value here. So yeah, whereas all of the other 8 firms, so very, very high contribution here to their respective dimension. So we can note it down here, the SPAT and HI. We look at the SPAT and HI, where I here SPAT and firm I here are have a lowest contribution to the initial of point for their respective dimension. So yeah, remember that this is just the explanation by dimension fit, which is indicates the proportion of category variation accounted for by the dimension. Yeah, so we can.
It's very clear. Yes.
Yeah. So see, you can take the correspondent rule of thumb for the correspondent. So they say here the correspondent analysis is suitable for the exploratory research and is not appropriate for hypothesis testing. Yeah, so this is a form of compositional technique that require specification of both object and attribute to be compared, which is one of the difference point which we compare with the MDS. And correspondent analysis is very sensitive to outlier. Does MDS sensitive to outlier? No, right? We know from that the previous class that the MDS is not sensitive to outlier, but the correspondent analysis does. So we should eliminate the outlier before we running the technique.
Good.
Yeah. So you can read more. So I just conclude by a little bit comparison between the MDS and correspondence analysis. So all of these two methods are all can help in the understanding of particular type of data by visualizing or displacing the data in a graphically way. I mean, in the perceptual map. But why MDS apply to proximity matrix, and this technique is very useful in unraveling or discovering the dimensions in which similarity judgment can be made or are made. Whereas the correspondence analysis often allow more insight into the pattern of the relationship in the form of a contingency table. You can see, if you remember the last week, we see the perception map derived from the MDS, and we see that we have to rely on another software or another analysis we can name the dimension to interpret the dimension, right? But for the correspondence analysis, we can easily interpret the dimension. Because why? Because the CA allow more insight into the pattern. So we take into the consideration the firm and also the attribute together. So based on attribute and based on the firm characteristic, we can somehow have some basic idea or some very meaningful interpretations that help to interpret the result. As you can see here, by the relative contribution for each dimension, and the firm, and also for the attributes. Yeah. So the MDS allow for the comparison of firm. But CA result can provide a means for directly comparing the similarity or dissimilarity of firm, and also the attributes. The last point I want to mention here is that the MDS determine positions based on overall judgment, whereas correspondence analysis position firm according to the selected set of attributes. Yeah, so I just take it from the textbook and some other sources to see the difference between these two methods. Mm-hmm. So if you have any question, you can ask me or Professor. And finally, I would like to thank you, Professor, and all of you for listening. Thank you.
Okay, very appreciate the line, very clear and helpful ending. Can you leave your screen at the last page? Yes. This is our conclusion in our textbook. Please read your textbook, okay? Graduate student, you must independent study and do the practice, not just waiting for your teacher to show you something, to read the book for you. Now, please read it by yourself.